Dear students, hope uh, you are in good condition. So today we are going to continue for lesson 10, and we will cover pages between 265 to 269. The title is alcohol. Today we are focusing on alcohols. Alcohols are one subgroup of organic compounds, and so all alcohols have different type, and all of them, all the names ended up with all. Like alcohols is a general name, but which alcohols can be, as example, methanol or ethanol, all ended up with all. So another criteria uh, uh, for alcohols have um, OH group or hydroxyl group, and as you can see on the list here, and from the molecular structure you can see that all kind of alcohols that I put here, they have hydroxyl group. Okay, this is also a molecular structure. This just as extra information, this model called a space filling model. Okay, a space filling model of molecular structure. And another point for this section is alcohols. Alcohols follow this general formula CnH2n plus 1 OH. Okay, so if we have one carbon, that means we can get three hydrogen and directly connected to, like this here, methanol. If we have one carbon, three hydrogen, which is directly connect to carbon, and also another OH, which this section can be connect directly to oxygen, and the hydrogen which connects to oxygen. Methanol is very toxic, and methanol is meaning that we have one methane which gets old. That means methanol, or the methane which has hydroxyl group or OH group, so we call methanol. Ethane, if ethane get one hydroxyl group like here, so it would be methanol. Okay, we learned about the alkane derivatives, alkane compounds: methane, ethane, propane, butane, pentane, hexane. Okay, these if one of hydrogen replace have replaced with a hydroxyl group, so they get all, they ended with all, and they become alcohol. On the other side, ethanol is safe drink, but it doesn't mean that drinking too much is still safe. No, drinking too much ethanol can show some side effects on liver and getting fat and something, those things. Therefore, as ethanol can be drinkable, safe for drink, it's very useful to create different drinks like wine, beer, and some alcoholic drink. Here there are some example of ethanol alcohols compounds. The first one is methanol, the simplest one, only one carbon and three hydrogen, which directly connect to the carbon. And the second one in ethanol, and propan one ol, and butan one ol, and pentan one ol. So here, if you look at these pictures, you can see propan. We have propan one ol, propan two ol. What does different? So here, for example, in the hydroxyl group, if hydroxyl group uh, attached to one side of a propane, okay, like here, so this carbon can be one, so that's why we call this is propan, okay, propan, and one is the number of the carbon which hydroxyl group is attached. And two, you can see here that we have butane, that means four carbon, but hydroxyl group is not attached to the two side, I mean not the first carbon, the second carbon, okay. So this carbon, the second carbon, is the place of hydroxyl group, so that's why we call butane 2-ol, and butan 1-ol, and ethanol, and methanol. Methanol, it doesn't matter of the hydroxyl group in place in which side. So in all four condition, it would be methanol, same. And also methane, it doesn't matter that a hydroxyl group place in which side. In any side, um, in any side would be ethanol. And also one another note is increasing the chain in alcohol molecular structure also increase the boiling point. Increasing boiling point means if you want to get a vapor, if you want to get a gas, a formation of uh, this alcohol, you need to give more heat. For example, for pentan 1-ol, you need to give around 137 heat or temperature, then get the formation of vapor until it get boiled. Another slide is about making ethanol. I put more academic word, which is synthesis of ethanol. Later on, hope all of you go to college or university, and then later on you can see that instead we use making ethanol, we should say synthesis of ethanol. This is more academic word, and it's more suitable. Synthesis, that means you create, you make after a reaction. So synthesis of ethanol can be divided in two ways, either hydration of ethane or fermentation. So hydration of ethane is very fast, and it's industrial, can be used in industrial process. That means in this industrial situation, we need to get product faster, and also with a very large scale, not a small scale. As you can see on the equation, ethane is one alkane compound is for formation of the gas. If you remember, I said methane, ethane, propane, and butane, they are gas formation. The first four alkane compounds, they are gas formation. And if we use the steam of the water, which is hot, then finally we will get ethanol. That means one hydroxyl group, OH, can be replaced with one of the hydrogen here. We have two carbon and four hydrogen, so one of OH from the water can be replaced on one of these hydrogen. So hydrogen gas, I think, leave the condition. So we should use phosphoric acid or any other acid to make faster the reaction, and also high temperature. About fermentation is a longer story. I should explain more about this fermentation. Um, I think it's better first go to the next slide to get some background about fermentation. Fermentation used used since long time ago in traditional way when we keep the fruits, okay, or some other nuts, fruits, they have sugar. Actually, the sugar is not that one we use it for sweeten the tea. This is the sugar like such as glucose, cellulose, some or galactose, something like that. And we have such that type of sugar inside of the fruits and nuts. So if we keep those things um, in a water or in a container for a longer time, uh, actually they will not get the fruit or the body get spoiled, but they produce something. They produce ethanol, which is type of alcohol, and also they produce CO2, carbon dioxide. As you can see here, they are doing actually this is the way, also traditional way to make a beer or wine or some other related drinks. So as you can see here, one I'm not sure what is it, but usually fruits can be used for this purpose, and you can see lots of bubbles, which showing producing gas. The gas is carbon dioxide, and also these fruits leave ethanol in form of liquid. Okay, and but on this side you can see the laboratory process which used for making or synthesis the ethanol, and the glucose solution with yeast. After a long time, when you leave the fruits in the container, so the sugar or glucose can change and can synthesize the ethanol and gas. The gas can be trapped, okay, in airlock containing water, and also this airlock containing water has two rules, two responsibility. One is one is uh, trapping the gas CO2, and another one is protection of this equipment against bacteria. Okay, bacteria in the air. So so this is the purpose of using airlock containing water. Keep in your mind. So then finally you will get solution of ethanol. But this process can be continued until the concentration of your ethanol getting higher. When time passes, uh, fruits can be actually disappeared, and instead produce ethanol. So if you give more and longer time to this process, the concentration of ethanol would be higher. So let's move back to this slide and um, see the equation. This is the glucose, actually one type of sugar, contain carbon, hydrogen, and oxygen. And so if we use any enzyme which make faster the reaction, so finally after longer time you will get ethanol, which is a kind of alcohol, and also you can trap or you can leave the carbon dioxide. Okay, and this process is very slow, and it's anaerobic respiration actually. So there should not be oxygen. It's a kind of respiration but without oxygen. Okay, like human, we are breathing. Actually, this is a kind of respiration, but it's an aerobic. But this one is anaerobic respiration. There is no oxygen. If there is oxygen, oxygen disrupts the reaction. Okay, because the ethanol can react with the oxygen. So next slide, I will show you that ethanol is able to react with oxygen, which kind of combustion or burning reaction. And also I request you look at your book to find a comparing between these two methods. Actually here, hydration of methane, uh, hydration of the ethane, which produce ethanol, and also to producing the ethanol we use fermentation. There is two way to create or synthesize of ethanol, but there are some advantages or disadvantages for these two methods. I request you please read this table is important to identify the differences between these two methods. Okay, for example, the last one, fermentation is simple. You need just a container and leave the fruits for longer time, but hydration is more sophisticated and it needs some industrial equipment. And yeah, so next slide, we are going to focus on a reaction of ethanol. So so far we learned how we can make or how we synthesize the ethanol, and this slide shows us that what is the reaction of ethanol. The first one is combustion. As I said, if there is oxygen, um, ethanol would be able to react with oxygen easily, because ethanol is very highly talented to burn, highly talented to react with oxygen and produce a very high flame of the fire. As you can see, after reaction, carbon dioxide will produce, and also water. The water is a form of gas. Okay, it's a vapor. Some country like Brazil or other country, uh, they invested they invested for plants or uh, fruits like plants, leaves, many natural stuff to keep them and get ethanol, and then use the ethanol as a fuel for their car. So this is good. There are some advantages or disadvantages, and disadvantages for this. Uh, the good point is very clean. That's why this method or this way for using as a fuel is well known as a biofuel, but the negative point of this way is this is very slow process. You need to keep those things for a long time to get not very high concentrated of ethanol, and after that you need to purify also. So but this is a good way, and actually this is very good method for climate and uh, for the climate and these things. Okay, the second reaction the important reaction is oxidation. Um, Again, reaction between ethanol and oxygen can produce acid and water also. So this actually this is not O2, not oxygen gas. This is the only oxygen. Maybe from oxidizing of any agent, any other compounds, if we get oxygen, not O2, if we get only atom oxygen, each two atom oxygen separately can react with ethanol and produce acid, ethanoic acid and water. The book said vinegar is commercially produced from wine. So I explained that we use ethanol for making wine or beer. So if we have wine, okay, the wine means we have means equal. We have equally we have ethanol. So if we add some oxygen industrially, okay, or commercially, so we can get vinegar. Meaning vinegar is the same ethanoic acid or acids actually. Vinegar is weak acid, and this vinegar can be obtained from wine, the wine which exposed to oxygen. So the third reaction is dehydration. And the, I'm sorry, the hydration. The hydration is removing the water actually. That means when we're removing the water from alcohol, not only ethanol, okay, any alcohol, maybe here we have two carbon. If you have three, is another alcohol or four carbon. So any alcohol, of course, has hydroxyl group, and there are also hydrogen. Each one hydrogen from other side and hydroxyl in another side. If we get both together, so we can create one water, one molecule of the water, and the rest would be ethane. Ethane is a form of gas. Okay, ethane is a form of gas. If you look back to alkane, we discussed about reaction related to alkane. Okay, alkene has different reaction. One reaction is reacting with water. Okay, just I think we discussed the previous video. If you check, you can see alkene has one type of reaction with water, then produce uh, alcohol. This is actually reversed reaction. Okay, this is the opposite. When you have alcohol and when you remove or take out uh, hydroxyl and hydrogen, you will get, if you take out water, you will get alkane. Okay, so if your alkane react with water, so you will get alcohol. So this is one type of what we call, and is a two-way reaction. Okay, the reverse reaction. Another, the last one is esterification. Esterification means we are going to make ester, which we will talk about ester next time. Okay, next time I will teach you about ester, how we can create ester, what is the reaction for ester. But one way that we can make ester is synthesis of ester from alcohol. Is like this ethanoic acid. If you have ethanoic acid, one type of acid, reacting with ethanol, so we will get water and ethyl ethanoate. Ethyl ethanoate is one type of ester. What is the ester? Ester is the oxygen which is linked by two branch of alkane. Okay, alkane. Here is, if you can see, there is oxygen in the middle, and the other two side, left and right, there is alkane chain or hydrocarbon chain. We will talk about with more details about ester next time, and here I would like to explain more details about dehydration here. Okay, the third one. There is one experiment for hydration of the ethanol. If you look at here, we have rock silk and ethanol, which ethanol is not pure ethanol here. Okay, here also they use glass wool with ethanol is the mix. So we need to use a heat. Okay, our bones burner or heat, and also we need a catalysis. Okay, a catalyst, a solid catalyst. It could be broken pots. Okay, it would be aluminum or any other catalyst. It's usually it's a metal. After that, you have methanol. If you give the heat, the part of the water, I mean the hydroxyl and hydrogen, can leave the structure. This hydrogen and hydroxyl, because of the heat. Okay, when you give a heat, one hydroxyl and one hydrogen can leave the structure. The structure change to the alkene. Alkene is a form of gas, and we need to trap the gas by the pipe. Okay, by the pipe here. By the pipe, the gas leave this container. This pipe. Okay, can go to the another place, and the rest also you will get water. This water is a form of gas because of the heat, but the water can add to this water. Okay, in during the pipe, water and ethane, this gas, they are together during the pipe, but after they reach to another one, okay, another pipe, so this water vapor can be colden and add to this water, the liquid one. But the ethane gas can leave the liquid and go and can be trapped. Here, I think it's because of difference in boiling point, which can be separated. Please, if you see any such this type of picture in your book, try to read and understand the process, what's going on, because during your exam you will have one section as named experiment section, something like that. So you need to analyze the experiment. Okay, then you need to give answer to the proposed question. So I would suggest you, please, if you see such this type of picture in your book, please try to uh, read carefully and understand all the process, the steps. And if you cannot understand, please ask me, or you can search on Google. You can find similar explanation. Please have a look at this question that I put, and leave a comment, leave your answer in Google Classroom. Then I will check your answers. Question number 3, question number 4, and this is question number 5. Okay, take care. Thank you so much for your attention.